Welcome to the course. We're going to start with a brief map of the course and what you're going to learn, and then we will start writing code. We will start with more enjoyable and easy topics and build towards the more complicated ones. The $1 million question. What exactly am I going to learn in this course? Throughout the course you will learn what is and how to use LINQ. We will start with the most basic operations with query syntax and build towards more complex ones. Grouping operations with query syntax. Grouping allows you to group the items in a given collection by a given common key. For example, to group a list of people by their age. You will learn 5 different types of group operations. Join operations with query syntax. Joining allows you to join 2 different collections by a common key. So it's similar to grouping, but it does it on 2 collections and not on one single collection. You will learn the 3 major types of join operations and a few of their derivations. The let keyword. This is a keyword that allows you to create internal variables inside your queries. LINQ path is next on the line. There will be a short introduction to this nice piece of software that you can use while you study LINQ to better visualize the results of the operations that we perform. Then we will move on to LINQ with method syntax. Here we will reiterate what we have already learned about LINQ, but this time you will learn how to perform these operations with method syntax. Method syntax makes some of the operations easier to implement than the query syntax. We will also look at grouping and joining with method syntax, of course. Then we will look at filtering, converting, and ordering with method syntax. And while by this point you will already probably be familiar with the basics of these operations, there are things that need to be considered while performing these operations with the method syntax. You will learn what are the common pitfalls. We will end up with some cool operations that we can easily perform by using the LINQ methods, how we can generate different sequences of numbers, for example, characters, random numbers, and many other things. More interesting things like set operations, quantifying, partitioning, concatenation, and aggregation operations will also be explained. Of course, all the source code will be provided for each of the sections in the course in a nicely ordered and structured fashion so that you can use the code to practice and learn. I hope that you will enjoy this course, so let's just dive right into it. Alright, we're going to start with LINQ. LINQ stands for Language Integrated Query. It's very similar to MySQL, with the only difference that LINQ works on collections and MySQL works on databases. They both perform the exact same thing. Both are designed to extract some information from a collection or a database based on some conditions. All LINQ operations can be dubbed down to these 3 basic operations. First we get the source, then we create the query, and then we execute the query. Let's start with the anatomy of a LINQ query. The first thing that we have to do is that we have to define our source. We start with the keyword from. Here we define the variable that is going to iterate over the source. So iterating variable in the source. After that, we define some conditions by using the where keyword, and we select all of the new items that match our conditions. So let's see this in action and very simple example. So we're going to create the simplest example that there is about LINQ. We're going to use the var data type, first because we're always going to use different type of collection. Our final type may be different from that of the collection. So you'll always need to guess what is the type that you need to have for your query. So it's just easier to use var. Get the numbers is what I'm going to call my query. And we start, like I said, with the word from, with the keyword from. Also, you need to have this namespace added to your class file. You need to have using system.link. If you don't have it, you will have an error. And for some reason, Visual Studio doesn't see that you're missing the LINQ namespace. So in most cases, you have to add it manually. So from, I said that the first thing that we're going to do is use the iterating variable. So the name of our iterating variable will be number. It can be anything you want. You can just simply use the letter N, which is what most of the people are going to use, but I'm going to use the word number to better illustrate what is happening. And then we tell our query, which is our collection. So from number in numbers. And then we're going to select number. Currently we don't have any conditions. We're simply selecting all of the numbers in the numbers array. And we're going to print all of these new numbers on the console just to see our output. I'm going to use a quick and easy way to print arrays on one line of code. We discussed this trick that we have here in the C# Basics course. So here we define the separator and here we give it the source, which is get the numbers. And if we run our code now, you can see that we get the exact same numbers that we have here in the numbers array. Now, let's say that we want all of the numbers that are less than 5. We are going to use the where keyword and we are going to give it the condition. The condition is where number is less than 5. If I rerun the project now, we should be able to get all of the numbers that are less than 5 as it just happened. 3, 2, 1, 4, then we have 3, 4 and no other numbers that are less than 5. Now, before I try to describe exactly what is going on here, we're going to perform the same operation, but we're going to use a simple loop. You should be able to do this. You should know how loops work and you should be able to do this on your own with a loop. First, we're going to create a integer list because we don't know how many numbers we are going to have. That's why we can't use an array. An array needs to have its size predefined. So list of integers, new numbers equals new list. And here we're going to create a for each loop. So for number in numbers. And here, if the number is less than 5, we're going to add it to the new numbers list. If we output these new numbers now, the same way that we did with the get the numbers, we should have the same result. And we do. This is expected. Now, this is where I'm going to dwell a bit in the query to explain exactly how it works. Like I said, I intentionally used the number word so that I'm able to compare the query and the for each loop. Here we perform the operation in just 3 lines of code. And here we had to create a new list, we had to use a for each loop, we had to use an if condition, lots of brackets, and it's doing the same thing, but it's just much easier to do it with the query. The number is the iterating variable. It works exactly like it works in the for each loop, or in any loop for that matter, but the for each loop is much closer to the LINQ than a simple for loop. It works exactly the same way. The way that the for each loop works is that you give your iterating variable a name. It starts iterating on your array and it executes the code within the loop for each of the items in the array. So first number is equal to 5, then it's equal to 6, then it's equal to 3, loops through the whole array. The same exact thing is happening in the query. The number iterating variable first has a value of 5. It checks on the next line, it checks if the 5 is less than 5, and if it's less than 5, it's going to select it and add it in our new collection. But since it's not going to be added. 6 is not going to be added either, while 3 is less than 5, it's going to pass this check here and it's going to be added in the new collection. That's all that there is to the query. Just imagine that it's an easier way of using a for each loop. You can do much more complex operations with LINQ that would require a lot more coding than just 5 lines of code to do it with a for each loop. One last thing that I want to note here is that this query is not executed until you actually use this new collection somewhere. That is why executing the query is a third step. The query is not executed until you actually use it somewhere. So here we simply create the query and it is being executed down here when we try to access it. While the for each loop is going to be executed immediately here, and by the time we move out of the for each loop, we already have all of the new numbers here. So this is one of the differences between the two approaches to this problem. Now that you have a basic understanding of what LINQ is, we need to spend a few minutes talking about what these queries are returning, what is their type. We know that we can perform queries on collections, lists and arrays are collections, so you may think that if you perform a query on a list or an array, like we saw in our initial cases, initial examples, that your end result would also be an array. It's a logical conclusion, but an incorrect one. The first thing that should tip you off that something funky is going on here is that you can't access items directly from the result of the query. So you can't use indexers. If you try, let's try simple LINQ and use an indexer of 0, like so, we can't do this. It says cannot apply indexing with square brackets to an expression of type IEnumerable, which is the type of the query. This is the type that is returned by the query. Visual Studio is our friend and it tells us what is the type that it returns. So if we mouse over the simple LINQ here, you will see the exact same thing. It's an IEnumerable. Well, that begs the question, what is IEnumerable? Let's write it. Let's write IEnumerable. And if we press F12, Visual Studio will take us directly into the file of IEnumerable. And as you can see, it's a really small interface. It basically has only one single method. And this is the getEnumerator method. This interface has only one single purpose. And that is to enable the for each loop on a given object. This interface is what makes it possible for us to use the for each loop on a list, for example. So let's see what is in the list class. If we say list of integer and again F12, you can see that the list also implements IEnumerable. If the list class didn't have this interface, we could not use a for each loop on it. In fact, we wouldn't be able to create a LINQ query on a collection that doesn't implement the IEnumerable interface, because the from as in sentence, this first line of our query is basically a for each loop. We have already discussed this. And since the result of the query that we get is an IEnumerable, we can use for each loop on it. So instead of printing it directly on a single line like we did here, this is not always available to us. We could also use a for each loop, simple collection, to print the contents of the LINQ query result. Since we can't use indexers, we can't use a for loop. So we can't use for loop like this. We can't use the for loop here, so we can't say simple LINQ of I and do something with it. We get the same error, cannot apply indexing. And we will also learn how to convert IEnumerable to arrays and lists in a future lecture. Alright, so another thing that I want to show you is the enumerable class, which is enumerable like so, which is different than the IEnumerable. This enumerable class is a container class. It simply holds a lot of methods. Like you can see here, we have a lot of different methods. All of these methods are extension methods for the IEnumerable interface. As you can see, all of them start with this IEnumerable. So all of them are extending the IEnumerable interface, the IEnumerable type. These methods are what allows us to perform LINQ queries with lambda expressions, which we will also see very shortly. We will also create our very own LINQ method when we get a bit more familiar with LINQ itself. Let's see a couple of other examples. You can use the where clause with any condition that will give you a Boolean value, true or false. It's basically what conditions do after all. So you can do much more than just checking for numbers. Let's create a new query. So I'm going to just move this down here. Remember that all of the examples that we're going to see here are available in the source code lecture every given section. So they're much nicer and ordered there than what you're going to see here. So let's create a new query that is going to work on the cat names string array. So we want to extract all of the cat names that have the character A in their names. So cats with A equals to from cat in cat names. The condition that we are going to use is actually a string method that checks if a given string contains something. So we're going to say where cat.contains, and we're going to give it the value for which we want to be checking. So we want to check if a given name contains the character A. If that is the case, we want to select this cat name and add it in our cats with A collection. So select cat. Alrighty, and let's use the same approach that we used here to print it on the console. Cats with A. I'm just going to comment this out. Alright, so I increased my console size a bit so that it's easier for you to see. Here are the names: Bella, Luna, Simba, and Oscar. You can also have multiple expressions, multiple conditions in the where clause. So we can also say where the cat name contains the letter A, and it's also less than 5 characters long. So cat.length is less than 5. And we can use brackets to make our conditions more readable. Alright, let's run it and try again. And Luna is the only name that contains the character A, the letter A, and has a length of less than 5. We can do the same example down here with our numbers. We can say where number is less than 5 and where number is more than 5, for example. So number more than 5, again brackets, again and again, and get the numbers. I'm going to uncomment it. Let's try again, and there are no such numbers because this is a nonsense. It is to be expected. There is no number that is less than 5 and at the same time more than 5. So if we say 10 here and we reverse the signs, we should get the numbers that are between 5 and 10. 6, 6, 7, 8, 6, 7. Perfect. You can also split your conditions into multiple wheres on multiple lines. So instead of saying number more than 5 and number less than 10, we can do it like so. And here we don't need the brackets anymore. It's going to work the same way. We can do it up here as well. If you have long and complicated conditions, this is how you can split them into different conditions to make them more readable. They're going to work in the exact same way. Alright, one last thing that I want to show you here is that, as you can see, the numbers that we get are not ordered. 6, 7, 8, then again 6 and 7. Let's order them. We have a special keyword for this, so we can say order by, and here we need to tell it what is going to order the numbers by, and we want to order the numbers by the numbers. So order by number, let's run it and see the result. 6, 6, 6, 7, 7, 8. You can also order them in descending order, descending, by simply using the keyword descending, like so. I didn't word the use ascending because ascending is the default way in which the numbers are going to be ordered. So regardless if you use it or not, it's going to be ordered in ascending way. Basically, this is what you do with LINQ. Things will get more interesting in the next lecture, where we will start working with LINQ queries on objects. Alright, let's practice the same stuff, but now with objects. It's a little more interesting with objects. I have created a simple internal class called person with a couple of fields, a couple of properties, nothing too complicated, and a constructor, of course, so that we can create instances of that class. An internal enumeration gender. So, and I have prepared a list of people, a list of objects that we're going to use for our examples. Now, let's minimize it. Let's say that we want all people whose name is exactly 4 characters long, and we want them in a new collection. We want to separate them from the others for some reason. So, var 4 characters people equals 2. Now, I'm no longer going to use a whole word for the iterating variable. I'm simply going to use one letter. So I'm going to say from p in people. Usually people use only one character for iterating variables. In lambda expressions, they also use only one characters. We're going to see lambda expressions very soon. So when you see one character for a name, you know that this is either some input for a lambda expression, or in our case, it's the iterating variable for the given LINQ query. So we want to select all people that have names that are 4 characters long. So we're going to say where p.name dot length, so the length of the name, is equal to 4. And let's wrap it in brackets just to make it more readable. And here we're going to select these people. Now we can't use the string.join trick that we had in the previous videos, because here we have a collection of people and we want to take their names, so it's not as easy as it was for the names for the strings and the integers that we had. So we're simply going to use a for each loop to print these names on the console. So 4 characters people, and we're going to print item.name. Let's try it. And we have, all right, so we have John, Anna, Kyle, Anna, John, and we are missing Maria and Todd because my name is not long enough. Let's see another example. Now we want all of these people, but we want them ordered by their weight. So we're going to say order by. Remember in our previous lecture where we used the order by on the numbers, we ordered them simply by the numbers, ascending or descending, but since we are dealing with something more complex here, like an object, it has many properties, in our case just 3 properties, we can order it by some of these properties. So we want to order them by their weight. So order by p.weight. It's as simple as that. So we are going to modify our console write line a bit. I'm going to fix this really quickly. This is string interpolation. We used it in the C# Basics course. So name and the weight of this person, like so. Weight. All right, let's rerun it. So the weight: Anna 48, John 55, Kyle 77, Anna 77, and John 88. So they are ordered by their weight. As you can see here, the Anna with the 48 weight is after the John with 88 weight, who is last in this example. So this is the sign for string interpolation. It basically allows you to use variables directly inside your string by using curly brackets. All right, so moving on. What if we want to extract the names of these people into a new collection? The names themselves. We want to create a new collection of strings that holds all of their names. We no longer want the people object, the person object, we want the names. It's incredibly simple. All we have to do is modify our select row, and here instead of select p, we are going to say select p.name. And notice that here now we are going to have an error because p.name is a string. It doesn't contain name or weight properties. So if we delete all of that and leave it just like this, we should get only names. And there it is. Anna, John, Kyle, Anna, John. We no longer have any properties here. We have all of the string methods. And if we want, we can order the names. We can say order by p.name. And if we run it, we get the names ordered. One last thing that I want to show you here is that you can have multiple orders. Just like we can have multiple where clauses, we can have multiple orders. So I'm going to switch back to the object only. And here we're ordering them by weight. Let's say that now we want to order them by their name, and then we want to order them by their height. So here we're going to say order by p.name, name, and p.height. So we're going to change this to height. Let's run it and see. So we have Anna, 150, 164, John, 60, 70, and Kyle is last. There is nothing to order him with. There is no other Kyle, but he is still alphabetically ordered compared to the rest of the 4 people here. So it's as simple as simply by adding another criteria for the order by clause. Now, if you want some of these properties to be ordered descending, you have to use a descending clause, of course, descending keyword, and you can use it individually for each of these properties. So we can say descending on both of them. So we can run it again, and alphabetically it's now descending, and the same goes for the weights. If it's now height, not weight. If we change this to ascending or leave it without anything, alphabetically they are ordered in descending order, but now the heights are in ascending order. We're going to continue with LINQ, but in a different way. We're going to see how we can do this with lambda expressions, which is nothing more than syntactic sugar, as people like to call it, which basically means that you do the same thing by writing less code. Alright, lambda expressions. The lambda operator, which is an equals sign and bigger than arrow, depending on how you view it, is used to separate the input values on the left side of the arrow, of the sign, and the body of the code on the right side. So basically we have an input on the left side and some code that is going to work on this input. Simply put, it's a method without a decoration. It lets you create your method in the same place where you're going to use it, if that method needs to be used only once. It saves you the effort of writing a separate method. We will see lambdas in many different scenarios, and we will start with using LINQ methods through lambdas. We're also going to see them in when we talk about delegates, when we talk about events, and maybe when we talk about asynchronous programming. So the simplest example that we have is this here. It's probably not the simplest, but it's simple enough. We have an input, which is this n variable. Let's say that this is a number, n stands for number. We are checking if n divided by 2 has a remainder of 1. And then we're going to return some value to the variable that holds this lambda expression. When we check if a given number divides by 2 with a remainder or without a remainder, if we get a 0, it's an even number. If we get a 1, it's an odd number. So basically we're checking if n is an odd number. So let's see this in action. Here we have a list of numbers, and we want to extract all of the odd numbers from this list. If we used LINQ, we could do it the following way. var odd numbers equals to from n in numbers, where n divided by 2 is equal to 1, select n. If we print this on the console, we should get all of the odd numbers. Let's try it, and there they are. We don't have any even number. How are we going to do the same thing with lambda? We are going to say, we're going to take the numbers, and we're going to press dot and look at how many methods we have here. Some of these methods are available only because we are using the LINQ namespace. So we're going to use the where method. It's also it's also an extension method, and we're going to talk about extension methods very soon. So where, open brackets, and here it says something very strange. It asks for a func, predicate, and some stuff that is wow. We're not going to bother with any of this. We're simply going to create a new lambda expression, and we're going to use the example from the presentation. We're going to say where n, the lambda operator, n divided by 2 has a remainder of 1. And we're going to wrap this in brackets. All right, let's see if this is still working. It is working. So how does it work? The n is the iterating variable. So n is the iterating variable, just like with the LINQ query, just like with the for each loop, and it is going to iterate on the numbers array. So whatever you have here, this is the collection on which your lambda expression is going to work. This is the iterator for that collection. You saw the LINQ example a couple of seconds ago. It's working the exact same way. It's taking each of the numbers, using the code here that works on this input, checking it if it matches our conditions, and if it's true, it's adding it to our new collection. So we reduce the code even more. With a for each loop, we do it in 7-8 rows. With LINQ, we do it in 3 rows, and with lambdas, we do it in a single line of code. The lambda expressions are simplifying our life even more. Like I said in the previous video, lambda expressions are simply syntactic sugar. We're going to talk about the difference between select and where. If you look them up on the web, you will start finding complex explanations how select projects and transforms, and you'll simply and bluntly get a headache. So allow me to show you the difference between the two with a simple explanation and a simple example. At least I hope that it's going to be simple enough. Let's take our list of warriors that I have created here. It's just some object that I named warrior, which simply has one integer property. Let's say that we want to take all warriors that have height of 100. We know how to do this. We're going to say var short warriors equals to warriors dot where. So we're going to check the height. That's why I'm going to name our iterating variable wh dot height equals 100. Simple enough. Let's check it out. Let's see if it's working. Breakpoint and short warriors. We can see that we have 2 warriors, and if we check the warriors, we can see that we have exactly 2 warriors that have a height of 100. Now let's say that we want to create a list of the heights only. Similarly to our LINQ examples, we are going to use the select method to select, and we are going to select only the heights. We're not comparing, we want the heights. So if we run with the debugger, short warriors, results, and we have the heights. We have a collection of heights. And if we want to get only the heights that are of 100, we have to say where, we have to use the where first. So where wh lambda operator wh height is equal to 100, and then we select the heights. So we select only the heights that are of 100. If we run the debugger again, we will see that short warriors contains only 2 heights of 100. So what is this sorcery? Why is it working and how does it work? Select returns a new collection from another collection. So we already saw this in action. It returns the heights, only the heights themselves, the values of the heights from the warrior collection. So it extracts them. But select can't apply conditions on its own, while where returns items from the same collection that match a given condition, and it returns them in the same type as we saw in the first example. So when we are working on a warrior collection, it's going to return warrior objects, those warrior objects that match the conditions. When we combine the two, we get the warrior objects that match the conditions, and then we use the select to extract the information from these filtered objects. So that's the difference between where and select. They simply help you to extract a new collection from another collection and apply some conditions. By the way, I have here one hidden method which we used in the C# Basics course. We used it to quickly transform a string array into an integer array. And as you can see here, we used lambda expression. We used the select method. So with the knowledge that you have so far, you should be able to explain to yourself how does it work, but I'm going to do it anyway. So first we're taking the strings and splitting them. This has nothing to do with lambdas, but when we split them, we get an array of strings. Then we are selecting each of the elements from that array, and at the time of selecting these elements, we are parsing them to integers and then transforming them into an array. That's it, how it works. So this is how this method worked, and that's the difference between where and select methods. I want to show you one little nice function that we have, and sadly it's available only to lists. So I'm going to transform this into a list. So list of integers, and here we need to say to list like that. And that little nice feature that only the lists have is a built-in for each method, which works exactly like the for each loop, but it's just easier to implement it, especially if you simply want to do something on a single line of code. If you remember a couple of videos ago when we talked about LINQ and we had the list of persons, we used a for each loop to print the contents of our filtered persons. And there I told you that there is no one single line way of doing it. Actually, I lied. And now I'm going to show you how we can do this. Let's simply say that we want to print the heights of all of our warriors. Since they are objects, we can use the string.join method. So string.join, if we use it, we are going to get some nonsense that is not going to work for anyone. If we do it like this, we get LINQ and lambda warrior, 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 warrior. Nothing interesting. But if we say warriors.forEach and we open brackets, here we can use a lambda expression that will select each of the warriors, and then so W for warriors, lambda operator, and here we're going to print each of these warriors. Console write line of warrior.height, like so. If we run it again, you can see that we get the printing. If we want to match the signature of the string.join method, instead of using console write line, we're going to use console write, and here we're going to add some space, like so. Similarly, we can use the same approach to our list of integers. We don't need it. We can use the string.join method on the list of integers, but just for lols, we are going to do it. Short warriors for each warrior height, for each short warrior, lambda operator, console write line, SW, and here we start on the line above it. It just got a little too messy. Alright, so we have built-in for each method that we can use to, for example, print the contents of a list of objects on a single line of code. So we don't have to use a for each loop. This, let's delete this here. This is the same as this. W in warriors, console write line, W.height. these lines of code, this and this, are doing the exact same thing in the exact same way. So that was just a little nice feature that we have available with lambdas that I wanted to show you. Alright, moving on to the next LINQ clause, and that is the group clause. It's actually pretty straightforward. The group clause lets you group items in a collection by a given key. What this means is that all objects in a collection that share a common value for a given property will be grouped together. So let's see how it works in action. We will be using our persons list again, and we want to group all of our people by gender. So we want to separate the males from the females. Var, we will call it gender group, equals to from p in people. We always start the same old way. And down here we're going to say group. So we're going to group the people, so each person we're going to group him by, this is another keyword that we have to use, and here we need to specify what is the key that we're going to use. So what will be the property that will be used for a group. So we say that we're going to group them by gender, so we're simply going to say by p.gender. And that's everything that we have to do. Another new thing for you here is that a LINQ query can end with either a group clause or a select clause. So we don't have to use select in this case. This is everything that we have to do. I want to print the results, but we have to do it in a different way. We can't do it the same way that we usually do it. We need to take one additional extra step. And this is because the group returns an I, as you can see here, it returns an I enumerable of I grouping of gender and of person. So it returns a collection of some I grouping interface that has the key and the objects. And if we take a look at I grouping, you will see that it implements I enumerable. So basically it's just another I enumerable. So we have a collection of collections. So when we have a collection of collections, we simply have to use nested loops in order to access the inner collections. So we have to say for each person in gender group, and here we are going to say console write line, and now we can access each of the keys that we have for our group. So we can say person.key. As you can see, this is pretty much the only thing that we have access to. The rest are some methods that we have. We're going to take a look at them a bit later. So let's print it as it is so that we see what is the result. So we get male and female, which are the keys for our groups. Now, if we iterate on each of these keys, so if we say for each p in person, and we console write line it, you can see that now we have access to the properties of the person object. So we can say gender. We can also use the names of the people. So we can say p.firstname, like so. Let's run it. And you can see males dot male, John male, so on. Females, the same story. And we can even indent it a bit to the right. There it is, it looks a bit better. We can also apply conditions just like we do with select. So we can say var group with conditions from p in people, and here we can say where p.h is more than 20. We want to group the people by age, and we are going to take only those that are of age more than 20. So group p by p.h, and there it is. Let's print it on the console. We're going to use the same approach. So for each, I'm now going to call this item variable, I'm going to call it key, since we know that this is the key, and we are iterating over the group with conditions. So console write line key.key, and we are going to iterate over the key. So for each item in the key, we're going to print so item dot age and name. So item dot first name, and we're going to indent it a bit. So group with 26-year-olds, only one person. 21 years, 2 people. 22 years, 2 people, and so on. So we have 1, 2, 3, 4, 5, 6 different groups. Let's say that now we want to get all of the people grouped alphabetically by the first character of their name. So var alphabetical group equals to from p in people, and we are going to group them, group p by p dot first name. So we said that we want to group them alphabetically by their names. So we will take the first character of each name. So we're going to say index 0. Let's print it on the console. Like, I'm just going to copy it so that it's a bit easier and faster. So the key stays the same, the item stays the same, and we only need the name in this case, like so. Let's run it again, and there it is. T dot J, John and John, A, Anna, Aaron, Abby, M with Maria and Maddie, and so on. We can also order our people, so we can order them by name, order by p dot first name. So when we get our results, they're going to be truly alphabetically ordered. So we start with the A and we end with the T. Alright, moving on to lambda grouping. As you already know, sometimes the method or lambda syntax is easier to read and implement than the query syntax. We have already discussed at length what grouping is, but since repetition is the mother of all knowledge, grouping groups the items in a given collection by a common property. For example, here we are working on a list of people. These people have gender. They have a gender property, male and female. And we want to create male and female groups. So we want to group all of the people into these two groups. And this is what grouping in LINQ does. And it doesn't have to be just gender, as we will see in a minute. It can be any property. So how do we perform grouping with lambdas? We start off by creating our query variable, of course. So simple grouping equals, then the collection dot, and then we have to use the group by method. Group by method. All that this group by method asks from us is the key by which we are going to group the items in the collection. As you can see here, this is the only argument that is required from us in the list of arguments for the method. So group by, we are working on the people, so we are selecting each of these people, lambda operator, and we want to group them by the gender. So p dot gender. That is everything that we have to do. Of course, end with the semicolon, and that's everything that you have to do. Look how simple it is. Compare it to the query syntax. It's much easier and much simpler to read. So let's print it. How do we print it? We're going to print it the exact same way. By the way, just like the query syntax, the group by method here also returns an IEnumerable of I grouping. So we are getting the exact same result that we had in our query syntax examples, which means that we can print them in the exact same way. So let's create a for each loop. This for each loop will iterate through the whole collection that we get. So simple grouping, we have to get the gender, we are going to get the key. So we're going to say gender, and here we're going to say item dot key. The key will give us the gender, the current gender. And then we need a second for each loop that will iterate over the people themselves. So we are iterating on the items, and console write line, the p dot first name. Let's print it, let's run it. And we get gender male, gender female, and all the people in these genders, in these gender groups. So We can also apply conditions, and to do this we simply have to use the where method. So all that we have to do is say dot where before the group by, because we want to filter the results before we group them. So where p, so we are again taking each of the people in the list, and we want to get only those with age more than 20. So we're going to say p.age more than 20, and we are chaining our extension methods, our LINQ methods. And as you can see, we have fewer results. We can even list the age right here. So p.age, run it, and we have only results with age more than 20. All right. We can also group our people by their name alphabetically, again, just like we did with the query syntax. It's really simple. So all that we're going to do is var alphabetical group equals to people, and we're going to say group by p dot first name and the first character of the name. And if we print it on the console, we will probably get the correct results. So first we want to print the item.key, and then we want to print each of the people. So p in item, and we want to print the names, p dot first name, like so. Let's run it. All right, we do get the names with alphabetical ordering. Well, it's not actually alphabetical. We do get the first characters. So to truly get it in an alphabetical ascending ordering, we have to order it. So order by p dot first name, and this should solve it. There it is. The exact same results as with our query syntax. As you can see, with grouping, it's much easier than the query syntax. It takes a lot less calls to write the exact same LINQ operation. Now, that is not the case with some operations. It just so happens that the grouping is kind of easier than the query syntax, but that is not always the case. If we want to group our collection by more than one key, we are going to do it the exact same way as with the query syntax. We're going to use an anonymous object for the key. So this will look like something like this. So var multi-key, let's call it multi-key, and we are going to use the people again, and we're going to say group by p, and for the key we are going to say new open curly brackets p.gender and p.age. So this is our multi-key. So we will get our people grouped by their gender and by their age, which means that we will get, for example, if we have a person that is male and that is, let's say, 22 years old, and we have another person that is also male and 22 years old, they will end up in the same group. So let's go ahead and print the results. So we want each item from the multi-key collection, we want to print the key, so item.key. The key is our group, the specific group, and then we want to print the results for each of these groups. So we want to print the person in each of the groups, and we only want the first name, since the key will give us the age and the gender. First name, p.first name. All right, let's run it. And as you can see here, we have two genders, two males with age 22, both are called John. We have two Johns in our collection. Down here we have two females, age of 19, Maria and Maddie, and we have another result. Each of the other people is alone in each of their respective groups because there are no other matches. And of course we can order our groups by items in each of the groups. So this time we're going to do the ordering after the group by method because we don't have the groups before the group by method. So order by p dot count, like so. If we run it again, we should get, yes, we get the double results last, and first we get only those that are first. And you can play a bit with this, you can use a bit more orderings, but this is the general idea of the multiple key. Alright, joining with method syntax. Join is the operation that we use whenever we want to group two collections by a common property. We have our lists of buyers and suppliers, and we want to get all the buyers in each respective district of the suppliers, so that we know which buyers are close to which suppliers. We have to use the join operation to achieve this. So let's begin. The first type of join that we are going to explore is the inner join. So var inner join equals. We take our first collection, we say we use the join method. It's pretty straightforward, and here is where the hairy stuff is coming about. So the first argument that we need to give it is the inner collection, and this is our other collection, so the buyers. Then we have to give it the outer key selector, or the selector, the key from the outer collection, the suppliers in this case. We have to do this with lambda expressions, so we take each of the suppliers and we take the district from these suppliers. Then we need to give it the second key, that is of the inner collection of the buyers, b.district. And finally, we need to specify what is our result. Now, for our result, we need two inputs to the lambda, both the suppliers and the buyers. So we need variables for both collections, s and b. And the lambda operator, we are going to finally create a new object. In this new object, we'll have the supplier name equals s.name, the buyer name equals to b.name, and the district equals to, it doesn't matter where we are going to take the district from. We can take it from the buyer or from the supplier. It's going to be the same district, so it doesn't really matter. So s.district, and since these two property names are the exact same, we don't have to specifically say it. We can leave it like this, but I think that it looks a bit better like this. It doesn't really matter how we're going to do it. And finally, we want to print our results. So we want to say for each item in the inner join, we want to print the district, which is item.district, and we want to print the supplier name and the buyer name finally. So buyer supplier name and buyer item.buyer name. Let's run it, and we get all the districts with the respective supplier for that district and the buyers for that supplier. Alright, if you want to join two collections by more than one key, or in other words, you want to perform a composite join or a join by a composite key, we're starting off the exact same way. Composite join equals suppliers dot join. We still give it the second collection and buyers, and here comes the different part. The only difference is that we will create an anonymous object for our keys. I'm going to move it on a new row so that it is a bit more readable. First, again, the outer collection, so the selector for the outer collection, for the suppliers in this case, equals new s.district. So we're going to join by district and by age, s.age. Then we need to give it the second key for the inner collection, which is the buyers, new b.district and b.age. Now keep in mind that just like with the query syntax, these two anonymous objects must be identical. And finally, we need our result. And our result will be the exact same. We still need to take both the supplier and the buyer and create a new anonymous object like so. Supplier name equals s.name, buyer name b.name, and district. Let's print the results. So for each item in the composite join, we are going to print. So we're going to print item dot. Let's start with the district. We also need the age. I forgot about the age. So this is buyer name, and we also need the age. The age is the same for both the buyer and the supplier, since this is the key that we are using. So item.age, and we want to print the names. So we want the supplier, so item.supplier name, and we want the buyer, which is item.buyer name. Let's run it. So we get fantasy district, age of 22. The only match is the supplier Harrison with the buyer Johnny, and the only other match that we have is age of 35, supplier Haley and buyer Maria. So this is how you can perform inner join and inner join with composite key or composite join with method syntax. The last type of operation in LINQ that you need to learn about is the joining operation. There are three common types of joining: inner join, group join, and left outer join, and we will look at all three of them. Now, what actually is joining? In the most simplest way that I can put it is just like grouping, but between two collections. Grouping was grouping the items in a single collection by a given key, and in joining we need more than one collection, find common ground between the collections, and then kind of group them by the common ground. Now, let's start with an example. I have prepared two lists of buyers and suppliers. Imagine that you're the guy that brings the stock from the suppliers to the buyers, and you want to find out which buyers are close to each of the suppliers. So when you take the stock from a supplier in the fantasy district, which buyers are the closest one that you can go to first? So which buyers are in the same district as the suppliers? This is the common point of interest, the common ground, the district in which the buyers and suppliers are located. So we will perform the join operation by the district. Let's start the query. Let's first minimize this. Var, this is inner join. So we're starting the same exact way that we always do with from. For the inner join, it doesn't matter which collection are you going to select first. It really doesn't matter. So we can say either from B in buyers, or we can say from S in suppliers. I'm going to go ahead with suppliers, but for inner join, for this specific type of joining, it doesn't matter which collection you choose first. For some of the others it matters. So from S in suppliers. On the next line we continue with join, the new keyword that we are learning about today. You can look at the joining operation at the join keyword as you look at the from. We have the exact same signature, so we have to say join B in buyers. So if we change this join to from, it will be just like a normal from expression, with the only difference that here we need to continue and we have to say on, and this is where we have to specify the common ground, the key by which we are going to join these two collections. So we said that this is the district, so I'm going to say s.district. The last keyword that we have to use, the last new keyword, is the equals keyword b.district. Now, this is a very important step. You have to provide properties on both sides of the equals operator that are of the same type, so that they can be compared. The equals keyword is comparing these two common grounds. On the left side of the equals operator, you have access only to the first collection. So this is why here I said s.district equals b.district, because here we don't have access to the b. As you can say, b.district, it doesn't work. So on the left side we have access only to the suppliers in this case. So left side access to the first collection, right side access to the collection on the second line, the second collection. So the final step that we need to execute is to select our final result, of course, by using the select keyword. So let's create a new anonymous object that will hold all of the relevant information that we want about these buyers and suppliers. So we want the name of the supplier, so we're going to say supplier name equals s.name, buyer name, b.name. Now here we have access to both collections, and we also want the district. Now, since we're joining by the same district, the suppliers and buyers that end up in the same spot, let's say in the same anonymous object, will have the exact same districts. That's why I'm only going to say district once. And just like our previous examples where we created anonymous objects, if the name of the property that we want to create is the same as the property that we are assigning, we can skip the name. I'm going to simply say b.district, and district will be the name of the property. It's pointless to say district equals b.district. Alright, and let's now print the results. So for each item in inner join, console write line, and let's first print the items directly. And you can see that we got all of the suppliers. So we have the supplier Harrison, 3 matches for the supplier Harrison, with 3 buyers, 3 different buyers for the Harrison that are all in the same district. Same goes for the rest of the suppliers. Now, let's make it look a bit prettier and easier to read. So let's use string interpolation and district item.district supplier item.supplier name and buyer item.buyer. Let's print it. And there it is. It looks a bit prettier. So district, fantasy district, supplier, buyer, and so on. We can order by district if we want. So order by s.district, and we will get the districts ordered alphabetically. Now let's see another example. Here we have an array of objects. As you can see, this array is a very strange array, and it has integers, strings, characters, list of integers. It has, yeah, that's all that it has, but it's still strange enough. So let's say that you want to extract all integers from this array. We can very easily do this. Var all integers equal to mix of type. We only need to use this of type method. Here we need to use angle brackets, and we need to tell it what type are we looking for. We are looking for integers. Int, open close brackets, and that's everything. We don't have any lambda expressions yet. I'm going to show you why. Lambda expressions are when we want some conditions. Let's just confirm that it's working. So string.join of all integers, run it, and we have 1, then we have 1, 2, 3, 4. Let's check it. 1, 2, 3, 4. All right. So we have all integers. So here, if you have followed the project in the other course, if you were in the other course, we have a base class of character, which is an abstract class, and melee and spellcaster classes are derived from that class. So here, because of the polymorphism, we are able to extract the characters from this list into melee and spellcaster lists. But here we are using a for each loop to do this. And this is what? 10 rows of code. We can, you guessed it, do it in just a single row of code. Well, 2 rows, because we have 2 lists. So there are 2 ways to do this. We want to basically what we are doing here is we are extracting a derived type from a base type collection. Sounds complicated, but it isn't. So melee team equals characters of type melee to list. This is the first way that we can do it. It doesn't involve lambdas, but it's an easier way to do it and it's easy to read. Just to check it, we're going to put a breakpoint here. And here you can see that melee team has 3 items in it. It has a warrior, a knight and an assassin, and the spell team currently has nothing because we stopped before the for each loop. The second way in which we can do this is by saying melee team equals characters where, we're going to use the where, which will require a lambda, where C standing for character, C is melee. And in order to make it work, we can't just simply say toList. We're going to get an error. Although it seems logical and nice, we have one additional step here. We have to say cast to melee, like this. Let's run the breakpoint, the debugger. We can see that we still have 3 items. So we can do the same thing for the spell team. Characters where C is spellcaster, cast to spellcaster to list. And we no longer need this. We no longer need it. If we run the project, it's still working. And I also want to show you the equivalent of the type method with the query syntax. So if you want to get all of the items from a given collection that are of a specific type, so you have a collection of different types. In this case, I have a collection of people and they are of type person, of base type person, but they have their specific types, buyers and suppliers, and they are inheriting from this person type. And if you want to get all suppliers from this list, what you have to do is simply create a new query, of course, var suppliers equal to from p in people. And here is the tricky part. We simply have to give it the condition to filter these results by the type. So where p is supplier. Now this is the magic here. We can use the is keyword, the is clause, whenever we want to compare if a given variable, iterator or whatever is of specific type. It's much easier to read. And finally, we will select those that are suppliers. If we print the results on the console, item in suppliers, we're going to say print item dot get type. So we only want to check the types of everything in that collection. So we have 2 suppliers, just like we have in our list, in our collection. The same thing goes for the buyers. If we want to get the buyers, we simply check if the current person is of type buyer and we get buyers. We can also include another condition here and we can check for if the current person is of the specific type and a given property of that person matches the condition. So let's say that we want to check we want to get all buyers that are of 20 years old age. What we have to do here is we have to first typecast p into buyer, because if we say p dot, we don't have the properties of the buyers because the base type, the type of the people in the object is person, and we need to typecast it into buyer. The way that we're going to do this is we're going to use brackets and we're going to say p as buyer. So now this expression inside these brackets is simply a buyer. The p is typecasted into buyer, and when we press dot we get the age property of the buyer, and we're going to check if it's of age 20. And if we run it again, we get an exception, and the problem here is that we are typecasting it to buyer and checking the age, but we don't know if our current object actually is able to be typecasted to buyer. So first we need to check if that object is a buyer. So we have to say where p is buyer. And if we run it again, we get the correct results. We get only 2 buyers this time. Now this is not very readable. It is readable, but it can be a bit simplified, especially if you want to check more than a single property of the age. So what if we want to get all buyers that are of age between 19 and p as buyer dot age less than 22. Here we have an and. So we are typecasting the buyer 2 times and it loses readability. What we're going to do is we're going to extract this into a let variable. So let b for buyer, short for buyer, equal to this without the brackets, we no longer need them, and here we're going to substitute with b. So now whenever we need to use the person as a buyer object, for example here with conditions, we simply are going to reference to the b variable. If we run it again, it's working. Finally, the of type method that you saw earlier, the way to perform this exact same query with the where conditions here, we simply need to, let me delete it, I'm going to finish this query. So we simply need all people of type buyer where, and here we only need to give our age condition. So where buyer with b.age equals 20, if we run it we will get 2 buyers. So this is how you can filter by type.